Good afternoon. Welcome everyone to our webinar on bringing intelligence to OpenEdge. So embedding agentic AI into your applications. I'm Nick Finch, CTO at inmydata. We've been building tools with agentic AI for getting them for 3 years now, and increasingly helping our customers build out the same set of tools for their OpenEdge applications. I've got a colleague of mine, Gary's just sort of watching the chat. If you've got any questions while we run through the presentation, feel free to just stick your hand up, and he'll allow you to, or just enter a question into the Q&A. Or if you put your hand up, Gary will enable your microphone so that you can actually ask a question. Feel free to just interrupt us at any point. So the first thing that I want to do is really just introduce what agentic AI is. So it's AI systems that are capable of autonomous action based on goals, some context that we give them, and maybe some constraints that we put around the activities that they can do. They can reason, they can plan, they use memory, and we'll generally give them some tools to allow them to interact with applications in the environment that they're in. And importantly, they're adaptable, so they can adapt to the situation that they find themselves in and to the constraints and the goals that you've given them. A couple of examples might be, you could have an agent that answered the phone and maybe took bookings or directed customers to a particular department. You might have an agent that you gave to, say, regional managers while they're out in the field, so they could ask questions about sales or products within a particular store that they were visiting. So that's what AI agents are, but I guess more importantly, how do we build them, and how do we construct them, and how can we use them? Well, obviously they're based on large language models. That's the key technology that allows us to build these things. And if you think about how a large language model works, we give it a prompt, so we ask it a question. And the first thing it does is it's really just predictive text on steroids. So it will predict the first word of the response that it's going to give us. And then it feeds that first word back into the large language model along with the prompt and predicts the second word, and so on. If you're using something like ChatGPT, you'll notice word after word just appearing in its response. And that's what's going on under the hood, is it's just predicting the next word until it's given us its entire response. What's interesting about that is it's a really linear process. If I was responding to something, so say the prompt was, let's generate a marketing plan. If I was responding to that, I'd have a think about it. I'd maybe write some drafts and I'd consider those drafts. We're not giving the large language model that opportunity. We're asking it to give us its first response, and we're just taking that response as it is. There's no time to think. There's no time to consider what it's how it's responding to us. So what we can do is we could change that approach a little bit. So say, again, we were producing that marketing plan. I might give a language model that prompt, so generate a marketing plan for me, but I'll take its first response just as a draft. And I'll then feed that into a second large language model along with a prompt that says, this was the original prompt. This is the draft that I have. Can you give me a critique of this particular plan? And then we could feed that into a third model and do the same again and say, this is the original prompt. This is the draft I have. This is a critique of that draft. Can you refine that model? And it turns out if you take that sort of approach, you get a much better response for whatever the original prompt was. In fact, OpenAI and companies like those have been using this kind of architecture and construction to improve how the models respond to us when they've got to the limits of how much data they can train them on. So if you just call those large language models agents instead of large language models, that's effectively what agentic AI is. It's just using these agents in a workflow, giving them time to think and to consider on how they respond. But if you take that analogy a little bit further and you say, okay, if I was building a marketing plan, I wouldn't just create a draft, critique it, and then refine it. I might do some research. I might go and Google the particular markets that we were building the plan for, have a look at the demographics of who was who we were selling to in those markets, and I would use that to inform my second or third draft of the marketing plan. And we can do exactly the same with our agentic workflows. So we can give them tools to say, do a Google search or to pull some information out of a database, or anything like that, to allow it to interact with the environment around it. So in this scenario, we might give it a tool to do a Google search to look for demographics within the markets that we were building the plan for, and it would feed those results back into the critique agent, for instance, when it's building that critique of the original plan. That Google search isn't a large language model. It's just another software tool, a web crawler or whatever it is, or something that accesses a database. But it allows that agent to interact with the environment around it. And we can take that a stage further. So again, if I was building a marketing plan, I probably wouldn't know how many times I was going to iterate through creating a draft, reviewing that draft, writing a second draft, third draft, fourth draft, whatever. Or I might do a Google search, and some of the information that I got from that search might direct me to go and have a look at a few other things, and do further searches from that. And so it wouldn't be a particularly linear approach that we see here on this diagram. And again, you can do exactly the same with your large language models or your agentic workflows. So there's different ways that you can construct this. So you might have a single agent that can send work to other agents that are particularly good at different tools, using different tools to get different results. And it might be a single agent that directs the whole workflow, sends jogs off to other agents, and then collates it all and gives us a response at the end of that. Or alternatively, you might hand it to a particular agent who does something and then decides which agent to pass it on to. And that's the way that you build up those flows. So there's different ways of architecting this that work better for different scenarios. But the idea is that you have this flexible workflow that can react to what tasks it's given and what's happening in the environment around it. And actually, the environment around building these agentic workflows has just exploded in the last 18 months. So I often show there's a website here that just collates all of the different tools that are becoming available within the agentic workflow environment. And you can see some of them at the top here. So we've got agent platforms, we've got productivity tools, we've got agent frameworks, voice agents, customer service agents, content creation, personal assistants, sales, digital workers, images, data analysis, and on and on and on. So it's a really vibrant part of the software industry, and it's the ability of the tools and the things that you can build out of them has just exploded in the last year and a half. So to give you an example of the sort of things that we can build out of these, I've got a little working example here. So the first thing I've got is a little progress application here. So all I've done is I've added a couple of tables to my Sports 2000 database. I've added a car table, which has got the reg number, the make, the model, and the year. And then I've got a booking table as well, so that you can register bookings against it. So if I start up my agent on the back end, and then we bring up front end.
Welcome to inmydata Autos. Could you please provide the registration number of your vehicle so I can look up your details?
Yeah, my registration number is GJ18YBR.
It seems I don't have your car details in our system. No worries, I'll create an account for you. Let me fetch your car details from the DVLA to confirm them with you. I can see the MAK of your car is an Audi from 2018, but the model isn't listed. Could you please confirm the model of your Audi for me?
It's an Audi A4.
Thanks for that. We've got your Audi A4 from 2018 all set up in our system now. What can I help you with today?
You tell me when the MOT is due?
Your next MOT is due on the 6th of January 2026. Is there anything else you'd like me to check or help you with today?
I'd like to book it in for a service, please. You still there?
Yes, I'm still here.
Sorry, I'd like to book it in for a service.
The next available booking date is the 11th of July 2025. Could you please confirm if that date works for you and also provide a brief description of the service you'd like?
Yeah, no, I'm busy on the 11th. Can I book it in for the 13th? And it's just an oil service.
All booked in for the 13th of July 2025 for an oil service.
So there you can see it's a pretty natural interface. If anything goes wrong, you can interact quite normally with it. If it makes a mistake, sometimes it mishears registration number. You can get it to, you can correct it. It will tell you what it's looked up. So it's actually a really natural interface that you can sort of deal with quite easily. And you can see it's entered my car, entered the database, and it's entered the booking. If I came back at a later date, maybe wanted to just check on that booking.
Welcome to inmydata Autos.
My registration number is GJ18YBR. I just want to check the date of my service.
Your service appointment is booked for the 13th of July 2025 for an oil service.
There you go. So you can see it's a very natural interface. It has the ability to interact, as I said, with the database behind it. So if we have a little look at how this was actually put together. So in the front end, the little website that we were looking at, that's a Blazor front end. That just happens to be our web development environment of choice. It could be a WebSpeed front end. It could be a React front end. It could even be something sitting in your GUI application if you wanted to. As long as you've got a web environment, you could just put a web view into your GUI environment if you wanted to. That's then talking to one of those agent toolkits, and that agent toolkit that we're using is called LiveKit. LiveKit's just very good at real-time interactions. So it could be video, it could be images. In our case, it's the speech. And all it's doing is it's providing the transport layer for that speech to the large language at the back end, and then vice versa. When the large language model responds, it's producing the speech and delivering that to the front end. The real sort of gubbins or the real action is happening in that Python backend. That's the agent that we've built, and I'll show you that in a little bit more detail. So that agent's using OpenAI as its model to provide the intelligence for the interaction that we're getting. And that model is given a bunch of different tools. We're giving it access to a DVLA API so it can look up car details, but we also give it access to a PaaS-OE interface to allow it to talk to the database, to read and write tables to the database. So if we have a look at that interaction with the Progress database in a little bit more detail, I pull this up. We can see here, all I've done is I've created a web handler using the wizards within Progress. So it's actually quite simple what's going on here. It's just a web handler, and then I've created a few very simple functions within that web handler. First one to get the car. So you just pass in the registration number and it outputs a tent table with the car detail in it. I've got save car, so you put in all the details, input all the details of the car, just as those input parameters. It checks whether the car already exists, and if it doesn't, then it just creates it for us. And then I've got get next available booking, save booking, and get booking date. All of those are just exposed through a standard Progress REST interface, giving me a web interface. And if I just show you, if I go to localhost get car, you can see there's the JSON response that we're getting on the back end. So all of that stuff's really quite standard. You'll be used to building these sort of things in a Progress environment. All I'm doing is I'm exposing that functionality and those particular APIs to my agents. So then on the back end, I want to build an interaction with my agent. So when you're coding these things, you are going to have to step out of progress and write something either in Python or in TypeScript. We probably recommend Python just because most of the examples you'll come across are written in Python. So it's just easier to get started. It's not a difficult language to learn. And you can get lots of help from the likes of ChatGPT. You can literally just upload your Python script and start asking questions about it. And ChatGPT in particular is extremely good at responding to that. You can even ask it for changes. It will explain those changes and build them for you. So it's really quick and easy to get started. So the first thing that I've built in here is my database driver. This is just a driver and a library within Python that is going to interact with that OpenEdge API that I've built. So I've got methods create car. It's dead simple. It's just building up the query parameters, making a call to that REST API, and then returning the details of the car. And I've got the same for the get car by reg, get next booking date, book an appointment, get next appointment, etc. So there's not a lot of code in there. It's dead simple, nothing difficult to do, really easy to find out how to do those sort of things. I've done the same for the DVLA. So that gives me my tool set that I'm going to expose to the agent. So this is my agent code, and this is really the core of building this particular agent. So you can see here I've created my OpenEdge database driver. I've defined a class that's going to hold the details of the car, so just the reg, the make, the model, and then this is my agent class. When it's created, the first thing it does is it passes these instructions to the model at the back end, and these are the driving instructions for what we're doing. So if we go and have a look at that, it's just plain English. It's dead simple. So you're the manager of a UK call center. You're speaking to a customer. Your goal is to help answer their questions or direct them to the correct department. Start by asking the customer's car registration number and look at details. If the user's registration number is in the database, you can answer their questions. Otherwise, and it gives instructions to go and look it up from the DVLA and then ask for the model because we can't get that from the DVLA API. And then you can now answer their questions. So you're literally just describing what you want that model to do in plain English. And then a little bit further down, then what I'm doing is I'm building these tools. So this function tool, this is just a little directive that tells the large language model this is a function it can call, and then I'm defining the function. And it's important that I give it a name that's easy to understand. So this is called look up car by registration number in database. And the language model is going to actually just use the name of that method, that function, to decide whether or not that's the right tool for it to use. And then if there's any input or output parameters, I'm going to annotate those as well. So you can see it's passing in the reg, and I'm just describing this is the car registration number. It uses my OpenEdge database driver to go and look up the car and then returns the car details itself. So really easy. And I've defined a bunch of these tools. So get details of the current car, just says if we've already got one. Add car details to the database. Again, you're passing in the registration number, the car, the model, and the year of the car. Look up car details from the DVLA. And again, that's just using my little API call that we've got for the DVLA. Same for looking up the MOT, looking up the tax due date. Get the date today. It's important to give the language model or the agent a way of looking up today's date. Most of the time, you're going to be using a model that was trained a few months ago. It will sometimes get the date right, but often it will just use the date that it was trained. So it's to give it a tool, and then it'll always use that tool to get the current date, and you make sure it's the right one. And there you can see there's a few other tools in there. So get next, available booking, book an appointment, get appointment bookings, etc. So really simple. I mean, it's a very different development analogy to what we're used to. You know, I'm literally creating a bunch of different tools, describing those tools, and then handing them over to the AI. I describe for the AI what I want it to do, give it the tools, and that's pretty much it. You then just put a front end on it, and away you go. The only other code that's in here is just this little entry point, and all that's doing is it's creating a session. It's defining which models I want to use. So the language model that we're going to use to actually drive the conversation. I've then got a text-to-speech model and a speech-to-text model. And and then I tell it to start with a welcome message. And again, that's just a plain English language message that's in my prompts. So you can see these things are actually really quite easy to build. Anyone can create a cool demo like this. There's only probably 200 lines of code in the whole thing to build it. And that's the easy part, really. Where it gets difficult is designing, deploying, and maintaining AI that's actually useful and works in the real world. And that gets a little bit more difficult because for a demo, it's nice and easy. I've got a sort of predefined script really that I'm using for this thing, and I've given it the tools that I know it's going to respond well to for those scripts. But when you put these things out into the wild and let people use them, because they're interacting in such a natural way, they'll never stick to a script and they'll ask something that's a little bit different. And that's where these things tend to break down, because as soon as you go off script, the language model sometimes will just make up an answer. Sometimes it will just say, I'm sorry, I can't answer that, and give some general information. And from the end user's perspective, that gets very frustrating, and people very quickly sort of lose interest in these things and say, oh, it looks good, but it actually doesn't work in the real world. So building something that actually can be useful to users in the real world takes a little bit more thought, and you have to build in exceptions and get it to hand off things to other agents or people in the scenarios where it can't actually deal with request itself. And you need to build in exception handling in there as well, and that needs to be done properly and needs to be done well. And that's where a company like inmydata can help you. Number one, we have an AI consultancy, so we'll help you build these things. We know which models work well. We've been building with them for, as I say, getting on for 3 years now, both internally building tools for our own analytics platform, but also building things out for customers as well. But we also deliver a data platform, which makes building these things more robust and much easier and much quicker to actually build them. So why do you need a data platform? Well, the key to making these tools more adaptable and more able to cope with those obscure examples or different questions that are coming sort of a little more left field is giving them much more access to the data that's in business applications that they're answering questions on. And there's a few reasons why that's not particularly easy to do. Number one, speed. If you're providing data from a business application, it's just not fast enough. It's fine when you're pulling out just single records like we did in the example earlier. But if you start to have to summarize 1,000 records, 100,000 records, even tens of millions of records to build those answers, it's just not quick enough. Those sort of things take 10 seconds, 20 seconds, a minute, whatever. And so the conversation just breaks down. It needs to be sub-second responses to keep that conversation going. Large language models can write SQL, but only when it's very simple. As soon as you start to ask them to put calculations in there, to do aggregates, or do anything slightly complicated, it tends to break down. It makes mistakes and gets no results. And so your conversation breaks down. And actually, nobody really wants to give an AI freeform SQL access to your business applications. It's just a recipe for disaster. In terms of data context, again, our business applications just don't have context around the data in them. Table names tend to be fairly obscure. Field names are obscure. There's nothing that tells the model how to join tables together. In terms of validation, if I ask something like, say, give me the sales for the last year, that could be the last financial year, or it could be the last calendar year. The model will make an assumption about that. And it's important that you as a user know what assumptions have been made and can drill into those. And then the big elephant in the room really is privacy. Companies are obviously reluctant to share their data with large language models, particularly when those models are hosted by third parties. There's a common sort of fear that, if I give a language model access to my data, someone else is going to come along a couple of weeks later, ask a question, and my sales results are going to come spewing out from behind that. So that's why a data platform is useful, particularly a data platform like inmydata. Number one, we provide an API that delivers sub-second queries, even on tens of millions of rows of data. So it maintains that conversational interface. We provide a conversational and a structured API so that large language models can query complex data without having to write complex SQL. We provide context to the data. You can rename the fields and columns and tables to give them sensible names, and you can annotate them much in the same way you saw me annotating those functions in the example we had earlier on. In terms of validation, whenever we deliver data from the platform, you can have a chart delivered alongside that, and that chart's interactive. So you can drill into it, you can see what filters are on it, and you can see what assumptions have been made. And in terms of privacy, the API access is always through API keys, and you can filter the data down to row or column level security. For that, you can easily turn those API accesses off. And when we deliver a conversational interface, we're never actually sharing the data with the large language models. And I'll talk you through that in a little bit. So what does that data platform look like from an OpenEdge developer's point of view? Well, the first thing is that you need to share the data with the platform. So the platform's hosted in the cloud, and we need to push data out of our Progress databases up to our inmydata platform. There's a couple of different ways you can do that depending on the environment that you're in. If you have a traditional on-premise database and you want to push data up to the cloud, then we have a little tool that you can install locally next to the database, our scheduler. So all you need to do is install a procedure library in the ProPath on your app server, and you can then use this tool to select the tables that you want to include in the export that you're pushing up to the cloud. You can build your for each for how you're joining those tables in there. So again, all ABL stuff, no SQL in here. I can put conditions, select the columns, add calculated columns that I want to. Again, this is ABL that we're putting in here. All of this to build up a query that we're going to push to the cloud. And then once you've built up your query, you can just schedule it and say, okay, push this up every day or every hour or every 10 minutes, etc. And you can start to accumulate your data up in the cloud and push it as regularly as you like. Alternatively, if you've already created an API for your data in OpenEdge, so for instance, here I've got I've got a sent table, TT order details like order, and then I've added in the order line details, and then I've got a little method here that basically pulls all of the order details out for Sports 2000 database, turns it into JSON, and then exposes that to my REST API. Again, if I jump in to my browser and we just look at, I run it, so that gives me basically an API that inmydata or any other third-party application can call to pull data out of the database. Obviously, in a real-world application, you put some security on in front of this. But once you've developed that, you can just log into your inmydata tenant and I can edit my subjects and just create a new, I'm going to call it delete me because I don't want to keep it. And it's a ND-JSON import, and there's my location I'm going to import it from. If you've got credentials on there, you can add those in. Click next, it will retrieve the data, it'll analyze it for me, decide what columns are in there. It then gives me an interface where I can change those columns, give them more sensible names. So I could call that order number instead of order none, etc. You can change data types. You can say whether you want to accumulate the data or just replace it all, and then just say what schedule you want to import it on. So let's say we'll pull that every 5 minutes or every 10 minutes. So really easy to create those imports to start pulling the data up to the cloud. So once I've got the data up there, we provide some components, which I'll show you, that allow you to get started really quickly. So you can drop things like AI chats into your interfaces. But then we also supply those structured and conversational APIs to allow us to build those agentic front ends for our applications. So I'll just quickly show you the components first. You can embed them seamlessly in whatever app you've got. It's very easy to brand them as your own. So in terms of branding, if I wanted to change and make sure the colors were the same as everything in my application, I can just come into the theme here, change all the colors, change the fonts, change all of the images. So it just blends seamlessly with my application. And we then have 32-bit, 64-bit OCX components if you've got old Progress GUI applications. We've got .NET controls if you want to drop them into a GUI for .NET front end, and we've got web components if you want to drop them into a web front end. Just to show you what those things look like, if I jump in here. So in terms of the web components, these are just a few little code pen examples. So for instance, I could pull up an AI chat. So it's dead simple. Just little web components that I can drop in. There's a inmydata Copilot component. I've got a second one here, which is the visualization. You'll see when it answers the question, I can show a chart based on that. So give me the top 10 stores based on sales of furniture in the last 20 days. So just to give you an idea of what goes on behind this chat, what we're not doing is sharing the data wholesale with any AI model. In this particular instance, you can change which models are used, but this one is using the Azure OpenAI API. So it's the ChatGPT model hosted on Azure. What we do is basically describe the data to the model, and then we're asking the model just to write code that we then execute locally within our own environment. And so you can see down here, it says somewhere down here, it will say I've got the data with 97 rows. That's just a data frame that we've created locally in our own environment, so it's not shared. And you can see very quickly, comes back with the results, and I can click on show charts, and it'll create a chart for me. I can see what filters are applied to that chart, so I can be sure. So it's giving me the date range for the last 20 days and where product group is like furniture. And you could drill into this. You could drag other columns in here. So I don't know if we wanted to see which salesperson, for instance, was making all of these sales. Really easy to drag that in, or you can just drill into it and see details. And again, as I said, these components are available in whatever front end you've got. So if I jump into where are we? My OpenEdge environment. So I've got a window here. It's got the inmydata analytics control on there. The only thing that I've a second one on. The only thing that I've done to this control is I've said the type of control is AI chat as opposed to any of the other types. And then the code behind that, I've literally just set the tenant for it. And then put some code to respond to when somebody clicks on the show chat API. And oops, I go back to that. Sorry. And just run it. So again, in my progress front end, I can say, show me the AI chat. Who were our top 5 salespeople last week? And again, it'll run through that, answer my question for me. Once we've got a response, it will give me a button. I can click on show charts. There's my top 5 salespeople, show charts, and it opens up a chart for me, which I can drill into and change and whatever. You can pick up the drill down events on that. So for instance, if you wanted to be able to drill down to a particular order and then open up the order entry screen, you can do. There's lots of different options in here. You can show the full inmydata API, sorry, UI if you want. You can show automated insights. So this pits out interesting things. It sort of watches the user, works out what the user's interested in, and then will pick out insights for that particular user. All of these things are sort of linked up to the AI chat. So if I click on an insight, I can then press explain this insight, and there's a pre-crafted question for me that will explain what's caused that particular change in the data behind it. You can show full visualizations of the data. You can show a full dashboard as well if you want to. So lots of options within those components. So those are our components. Again, as I said, you can drop them into any Progress front end, and there's code examples for GUI, .NET for GUI and for web. But what you also get with the platform is the API to allow you to build these agentic front ends. And there's two parts to that API. There's a structured API, which gives you simple data structures to pull data out of the platform. It always delivers sub-second responses, and you can ask it to return text, structured data, or charts. We also deliver a conversational API, so free-form conversational data access. It's really an API front end on that chat that we were just looking at, embedded in Progress or embedded in the web, and it allows you to return text, structured data, or charts. So if we jump into Python, I can just show you a couple of examples of that. And if I open up these simple examples are just available on GitHub, so easy to get started. First thing you have to do is just import the inmydata library. To install the library, couldn't be easier. Just pip install inmydata. That will install the library and all of its dependencies for you in your development environment. It's already installed for me, so it's just telling me it's already satisfied. Then just import it. I can then create a structured data driver, pass in the tenant that I'm connecting to. You need an API key as well. They're easy to create. You can just jump into your web front end. Here we are. So if I just go to API keys, just create an API key there, and that gives you access to the back end. And then there's a couple of ways of creating these structured requests. I can use a simple data filter, and a simple data filter is exactly that. I just put in the column that I want to filter on, and then the value that I want to filter on. So this is going to filter the data where the store is equal to Edinburgh. Really easy to create. So simple, in fact, that you can just describe it to the AI model, and it can create its own queries if it wants to. And then just tell it what columns I want back. So financial year, sales value. So that will give me sales for each financial year for the store Edinburgh. Alternatively, you can have more complex filters. So if you want to build up something that's a little bit more complex, we pass in the name of the column, the conditional operator. So that could be equals, not equal to, greater than, less than, like, contains, all of those sort of things. The value that you want to filter on, opening brackets and closing brackets, whether the filter is case sensitive. So in this case, I've just got two, one where the store's Edinburgh and one where the store's London, and I'm using the OR operator to join the two together and then just outputting the results. The key to this is just how fast it is as well. So if I Python just run this for you, once it's initialized, so you can see the responses come back in a fraction of a second. And there's 1.4 million rows behind this particular data set. Even if there was tens of millions of rows, you wouldn't see any difference in performance. It's really quick. So it's really good at supporting those interactions in a conversational interface. But also, if I want to create a new query, I want to draw different data out, I don't have to go back to my Progress environment, write a bit of code, expose that to my REST API, publish that to my app server, change my driver, and then put that into the code here. All I do is just create these little simple bits of code here. So it really speeds up that development, makes it much easier to access data and to write and to give your agents new tools and give them access to different types of data. The conversational interface is even easier to use, really. Again, I'm just importing the conversation driver, passing it the tenant that I'm going to use, and then I'm coding an event handler here. The conversational driver, it takes 10, 15, 20 seconds to actually build the answer and give a response, but it gives a description of what it's doing as the steps it's going through as it's building that. And so if you build those steps into your conversational interface, it keeps the conversation going and keeps it live. And I'll show you that in action in a little bit. But you can see here, basically, this is the one line where I ask the question and get the response. And again, if we just run that down here, so if I run my conversational data interface, once it's connected, so you can see these are the intermittent things that you're getting back, pretty much the same as we saw in the chat interface. So I'm going to see which subjects will be best to answer your question, subject I'll use is, etc. And then it builds your answer and gives you your response back. Generally, when you're building these things, the responses come back quicker than your chat bot can actually say them. So you tend to say, okay, just keep reading these out until you get an answer, and then just ignore the rest. And that gives a really nice conversational interface. The only other object that's in there is the calendar assistant. It just allows you to very easily get things like financial year, quarter, month, etc. from a financial calendar. So if I show you an example of how these can be used in a real world application. So basically I've built pretty much the same agent that we saw last time when we were looking at the car dealership, but this is for retail managers in a retail organization to be able to just ask any question they like about the data that's in their business application. Again, everything's pretty much the same apart from the access to the data that's coming out of our progress database. I'm now pushing that up to inmydata and then exposing that to the agent. So if we have a look at the code that we've got behind this, so first of all, my prompt is you're a helpful assistant for the manager of in my store retail organization in the UK. You can answer questions about products and sales in stores in the UK. We'll come on to what's in the rest of that in a few minutes. But if we look at, so here's my agent, same as we were creating it last time. There's a few extra things in here. Basically, I'm creating a structured data driver, a calendar assistant, and a conversational data driver. And then I'm defining my tools. So there's the same method to get the current date, to make sure that we're using the right current date. I've then got a bunch of things to get the financial year, to get the quarter, to get the month, to get the week, to get the financial period. I've got a tool here just to list the products. I've got a tool to search for products with matching name. It's quite important to put tools like that in. When you're listening to somebody speak, it's often the case that spellings can be incorrect, or it's going to slightly mishear what they're saying. It's certainly not going to be written exactly as it's written in the table itself. So you can get the AI agent to search things using a like operator, and that way it can overcome those sort of misrepresentations of product names. You can get product names from a product group, and then get information about a product, just returns the supplier, average selling price, and a few other things listing the stores. And then these are the tools that are really the crux of what's going on in this particular agent. So for instance, if we look at get sales value, I can pass in the store name, the product name, the year, and the week. But if you look at the description for these, the description for store name says the name of the store you want to get sales for. If you want sales for all stores, pass none. And then for product, I've got something very similar. So the name of the product to get sales for. If you want sales for all products, pass none. And the same for year and week. What this does is it gives a single tool where the AI agent, if it wants to get sales for a particular store, it can do. If it wants to get sales for a particular product, it can do. If it wants to get sales for a product in a particular store, it can do. And the same with year and week. So because we're giving it quite a lot of flexibility in how it passes those parameters in. And actually, the language models work really well with this sort of scenario. And so you can build a tool that can answer a whole myriad of different questions just by being sort of fairly sensible about how you word and how you deal with those input parameters. There's a couple of other things in here. It can say whether or not it wants to break out the branches, so whether or not the results should show values separately for each store, true, or just the totals false. Same for products. And then the last one is quite interesting. So how many results to return? If you want all the results past 0, if you want the top 5 results past 5, if you want the bottom 5 results past -5. And again, when we come at this from a traditional development scenario, you just wouldn't think of using a tool in this particular way. But just by describing it, giving it the example that you can use 5 to get the top 5, -5 for the bottom 5. The large language models, if I ask for the top 20, it will understand that, and it will pass 20 into that. Or if I ask for the bottom 20, it will pass -20 into it. And it's very good at following those sort of instructions. So you can build quite powerful tools just by being sort of quite intelligent about the way that you build up those input parameters. So we've got one here: get sales value, get quantities, get profit. These actually all just call this method down here, which is get sales information, which has all the same parameters, but then just a metric. So whether I want quantities or sales value, etc. And if I show you what that delivers us, so let's just run that. Jump to our front end.
Hello, Nick. Welcome. I can answer questions about products and sales at stores in the UK. How can I help you today?
Can you give me the top 3 stores based on sales last week?
I'm looking up the financial week for the 9th of July 2025. The top 3 stores based on sales last week were Liverpool, Birmingham, and London. Liverpool had the highest sales, followed by Birmingham and then London.
Can you give me the total sales for Liverpool last week?
The total sales for Liverpool last week were £261,703.62.
Can you give me the top 3 products we sold in Liverpool last week?
The top 3 products sold in Liverpool last week were Journey Girls Wooden Horse Stable Amazon exclusive, Shrinky Dink Misty White 6-sheet creative pack, and VTech Farm Fun Storybook.
For the VTech Farm Fun Storybook, how much did we sell of that last week?
Liverpool sold 1 unit of the VTech Farm Fun Storybook last week.
Can you tell me who the supplier is?
The supplier for the Tech Farm Fun Storybook is Harvey, Pagak, and Schmueller.
Okay, so again, you can see with relatively little code, we've got something that's really quite functional and can answer quite a lot of different questions. But if we look a little bit further down in the text, so in my code for that particular agent, so all of what we've built above was using the structured API, but then we've got a catch-all down here, so answer general questions. And this is just making a call to that conversational data driver, the get answer. And then if I look in my prompt down here, I said if the user asks questions about anything other than branches or products, always use the general question tool and not any other tool. And that, again, that goes back to what we were talking about earlier in terms of that exception handling, giving it a tool that it can answer general questions. So again, if I run this again and we then ask something about, say, salespeople, so jump back in.
Hello, Nick. Welcome. I can answer your questions about products and sales at InMy store branches in the UK. How can I help you today?
Can you give me the top 3 salespeople last week?
I'm looking up the financial week for the 9th of July 2025. I don't have a specific tool to answer this question directly, so I will need to look up the information for you. It may take a few seconds. Let me get the week number for last week and find the top 3 salespeople for that period. I'm going to see which subject will be best to answer your question. Would you like the information for the top 3 salespeople in the most recent completed week, week 27? Or should I proceed with week 28, even though it may not be a full week? Let me know which you'd prefer.
Week 27.
Thank you for confirming you'd like the information for week 27. I don't have a specific tool to answer this question directly, so I will need to look the information up. It may take a few seconds while I retrieve the top.
And so on. So you can see it gives it a tool that can answer those more general questions and pick out something that is that we haven't coded explicitly within the agent itself. Any questions? Anything that anybody would like to see in a little bit more detail? Heinrich's asking if there's different accents available. Yeah, no, absolutely. So if I just share my screen again, the speech-to-text engine that we're using here is something called Cartesia. So if I jump into Cartesia and just show you, you can have instant clones. You can even record your own voice, and it will speak in that particular voice. You can localize a voice. So if I select, I don't know, if I select Sophie, for instance, and then say I want her to speak Korean. I think you asked as well, Heinrich, whether we could speak other languages. Yeah, absolutely, you can do. So click localize. We'll call that Sophie Korean. Localize. And after a few seconds, it will give me that it will give me that voice. It will give me the voice in that particular language. And then it's just a key. So within my agent, I've just put our GUI ID. So if we get it to speak. Accept. Yeah, so you can have any language you like. You can have any accent you want. So one of these we were building for a company in New Zealand. We couldn't actually get a New Zealand accent. We started with an Australian accent. They didn't like that, so we got somebody to record something and created a voice from that, and that's what was used.
I think Tom's got a question there for you, Nick, as well, in the Q&A. It's the top 3 products that you drilled down into to a product that sold 1 unit. You're just asking if that was actually a correct value.
Yeah, it was, Tom. The data's it's just a demo database that we've generated. So I think the original data came from a jeweler's. And so, yeah, you've got jigsaw puzzles that are selling for $3,500. Often when I'm running that, I will respond, blimey, that is expensive. But then that sends the AI agent off saying, yes, it is expensive. Well, perhaps can look that up for you or something. So I tend not to say anything about it when I'm demoing it. But yes, yeah, it was the correct result.